So today we are considering the Seaborn tutorial. So here is the Seaborn web page where you can always get all information related to Seaborn as well as any updated APIs, objects you can always find here. And there's a good tutorials section. If you go there, there are a lot of nice tutorials out there. So today, in fact, we are going to consider some of the tutorials from this section, and we are going to see how we can use this features for us. Let's directly go into this Google Colab, and let's start installing Seaborn. So you can initially, just before importing the Seaborn, you can always do this part of installation, just a process. And then of course you can import Seaborn. Yeah. So that sets the stage for us actually. Basically, when we talk about Seaborn, just like Matplotlib, we already discussed about Matplotlib. So we are just going to have this Seaborn library, which we just had installed in it for using this as a powerful visualization tool. Just to import it here. Then let's set some few things as we move on. So since I have imported Seaborn as SNS, so whenever I'm going to access Seaborn, I'm going to use SNS, right? So let's, there are a few default settings out there. Let's set, say, we'll set theme. So there are a lot of styles and general settings, including the color palette or the grid system. I think we talked about it, like the markers, the grids, the colors. So these are some of the settings as we move on. We'll see how we can enhance the visualization part using all these settings. So this is a Seaborn setting. You can actually provide specifically what kind of settings you want. Like you can still the grid, dark grid, or the palette like deep palette, or any specific font you want to use it. Also, any specific scales you want to provide, you can always use these settings. That can be easily done. Then what we are going to do is like, so there are a few functions mentioned here among those settings. As we move on inside, we will later on include some specific themes and settings. So let's take some of the inbuilt data set. There are a few data sets that comes along with the so-called Seaborn. For tips is one of the data set. I'll explain about the data set in a moment. So tips.sns, we are trying to load it. We're going to load the data set tips. Actually, it's interesting that we have all the friendly typos are coming up. I mean, whenever you make a typo, it gives you the suggestion of the right thing to type. So yeah, now we are going to just use this data sets, tips data sets. So tips data set is like when you go to the restaurant and the customer is providing a tips, right? So what it has is that it has the total bill, the receipt, and the tips given for a specific receipt. For instance, like even when you go to a restaurant, you always pay a tips here in US. For instance, like sometimes it is like 15%, 20%, 25%, and so on, right? So you always have that option in the receipt itself. They give you an option like you have to sign in or you have to choose how much tips you want to give. So the receipt has the total amount and then you can add a tip to it. So the tip given is also included there. And to be more specific in this data set, they had some information about the customer, like the gender of the diner. If the gender is male or female, we can actually see this data set. And is the person who's dining, is he a smoker or a non-smoker? Certain restaurants has a place for those who smoke, right? Or sometimes smokers, they prefer to sit outside. And what day of the week? Is it like Monday, Tuesday, Wednesday, Thursday? So that actually influences the tips given. You can also see that. And then you do have the size of the party. For instance, if you have a group, and in that group, like there are 3 people or 6 people or 10 people, then again, what is the size of the group? In some restaurants, if the size increases and if you pre-book the number of seats or number of tables, then by default you have to give like 20% tips. And there are certain uh, rules in certain cities they follow. But anyway, we are going to consider this tips data set, which has the basic things like total bill, tips, the gender, and the size of the party, and the day on which the tips are given, and also it includes whether it's a lunch or dinner. Yeah. So we are going to provide a relational plot, and if you look here in the user guide, you will also notice there is an option for you to check with relational plots, right? So something similar we'll do. Here we'll try to go for the relational plot. So for using SNS, that's a Seaborn, we are going to use the replot. Replot is the relational plot. And for that data you're going to use is, okay, data equals tips. I think everything comes right there as your friendly typo companion. It's right there, right? Okay, you can put total bill. And then, so that's for your X, and for your Y, you can put tips. Of course, you have the columns. In the data set, you have several columns. It's like the time. We have the time hue, right? Hue is for the color. Hue equals smoker. Then you have style. Then you have palette. Palette is also the colors. We can palette set 2. Okay, let me put it as a size. Let me check the size. Okay. So what we are trying to extract in this data sets, usually the data sets are on the different columns of values there. So you have, anyway, in this x-axis, you have the total bill amount is there. And then the y-axis, you have the tips. And then you also have to try to find different columns that there. Like you have 2 of them given, time and the smoker. Let's see. Okay. So there is an error here, as you can see. Even the simple typos that you make can be huge mistakes as far as this kind of thing is concerned. So let's say data, I'm going to put tips, total. Okay. So I put as total bill. Actually, it's total. It should be total bill. It should be total underscore bill. So that's how the data set it has. So we have to just mention whatever in the data set. And then let's see any other things that we got it. Yeah, mostly we have, let me tell it, let me put it again. Okay. So you might encounter certain errors. I think this error is a named error. For that it says tips. Okay, I think they say the name tips is not found. It's okay. Okay, I have put this as tip. I should have put this as tips. You understand what is the problem here? So I have put it as they say tips is not found because initially when I load the data sets into this variable tip, I put it as tip. It should be tips actually. So let's rerun that one and then rerun this one. Got it? So another thing about working with Python for this data visualization is that whenever you encounter error, try to decode, debug those errors. And these days, you can also use certain AI tool to debug or to understand what the error is. But in this case, the error was quite simple. I just put it as a typo, like it should be tips, but I put it as tip. So it was actually looking for that particular aspects because here it is tips there. Okay. So here we have this different time, like lunch and dinner is out there. And for lunch and dinner, you have total bill out there, right? And for the total bill on your x-axis and on your y-axis, you have the tip. So based on that, you can see all these scattered plots gives us the values. But you do notice that whether the customer or the diner is a smoker or not, that is being distinguished based on the two different markers here. We have a star and kind of a bubble, right? A dot. And again, the tip size also varies, right? The bigger the size, the more the tip, you could say. So this is a simple one we can actually come up with, and then we can see how we can analyze this kind of data. As you go deep down into this data set, you can actually have different angles to it and see, say for example, which day of the week you have more tips or which day of the week we have less tips. And do we have to do something about getting more tips if you're a restaurant uh, holder? Well, anyway, let's go into other aspects of this code. Basically, we just started this out. Okay, let's go in deep and see how we can now define other aspects. So there are a few more data sets out in this part, but we are just starting with this data set. And if you remember earlier, we have been using certain tools like pandas, right? Pandas, and also we used libraries like matplotlib, and they also have certain default data set. So if you load certain data, like if you remember the iris data set, which we used while we are working with other libraries like pandas or matplotlib. Likewise, here also we have different data sets, so we can always go and use those data sets. So in this part, you also have code and text. For example, let me give you some data sets. There's a data set called flights. And Iris, I think you are familiar with, and Penguin dataset, and Diamond dataset, and Anscombe dataset. So this is the dataset that has different X and Y values, like different datasets, but their descriptive statistics, like mean, median, they are almost the same, right? If you recall that dataset. And then you have, of course, you have, I think, movie dataset, yeah, car crash datasets, and exercise dataset. There are a few datasets that I'm just mentioning here, but there are a lot more datasets out there. Geyser. So if you recall the old faithful geyser in Yellowstone, it's about predicting the geyser, how the geyser erupt, you can predict the time which it erupts. So these are some of the data sets. Perhaps I can delete this one. Let's try to load the next data set. SNS dot load underscore data set. Yep. We are using the iris. Iris, if you recall, that is the kind of species, different species of flowers under the iris flower category. And we are going to look at their petal length in that data set. Let's check out names of data set. Names. These are different types of data sets. Of course, in first they have a Titanic data set. I mean, Titanic, attention, diamonds, flights. Okay, so these are some of the data sets that's already there. Let's try to load some data sets here. Okay, I think you don't really have to do it every time the import because we already imported the Seaborn earlier, but we can actually import a matplotlib. So this data set, we'll try to load it. And then you are going to print this data set. Let's try to just print the head of the part. So that's part of the data set has been shown to us. So likewise, you can expand more onto this data set. Let's go further. Let's set up some style. Ticks. Okay, it gives a suggestion for ticks. Let's go for ticks. Let's let's go for this. In fact, we can go for the suggestion. Let's see if we can do it. Here's the dataset printed out for this, which we have already seen this dataset in different ways. But here is the 4 different dataset that is out there under this dataset, Anscombe. So we know that though the dataset looks completely different from the visualization part, but when you look at their descriptive data, uh, they're all like so yeah, actually for X and Y, since the data sets already have the X and Y, so what happens is that it just takes it right away here in this part. So if you want to specify some specific details, like for example, if you want to give some specific information on what you want to do it as such, let's change a little bit of this over here. So what I'm going to do is like, I'm going to give a title here. Let's put a title as data set. And then let's try to plot here. Let's see if there is a section like we have. Yeah, I have put the red color over here for this XY plot. And I put as data set 1, data set 2, 3, and 4. And we are connecting all the dots in this case. If you want to very specific information, actually we can still change a little bit. Let's change it. So what changes we have here is like we are trying to summarize this, the descriptive part of the statistics. We are trying to change it, and let's see how we can summarize this section. I think we didn't finish the earlier one is here, right? Okay. Okay, so this is fine. Let's So for you install Seaborn with matplotlib. Just to make sure we have the matplotlib over here. We can import. Seaborn is already there. Matplotlib, we just did it. I want to put some X and Y values. So here X and Y values were given, the X axis. So that's for the urge. You can compare them. In this part, I just put X as X, but here we are specifying this X as X value, right? You can change that if you want. Over here, you can actually change it for labeling the X and Y value. So sometimes you have to specify the labels, right? X value and Y value. So you can specify this information. In your data set, depending upon the data set, it might change actually the whole thing. So here I'm saying X horizontal axis value, Y vertical axis value. So likewise, you can actually make certain changes. Now let's import pandas actually, because pandas can also do a lot of work with regards to some statistical things. So we'll use the summary stats. Okay, I think we can just go follow the suggestion given here. If you follow the suggestion, you will be getting the summary of statistics for this particular data set. So summary means like here, just we have some descriptive statistics part, right? We have mean, the standard deviation. So these are some of the things that you can actually right away see. So once you make a typo, I think it doesn't really show you the suggestion. So better we follow the instruction as such. Okay, here again, you can specify details for X and Y. That's the different suggestion it's giving us right now. So you can specify for X, I need the mean of X value. So for X, I'm going to get the mean. And we also need for the Y. So perhaps I can put within the bracket, another bracket. So that's mean of x, then mean of y. Then your standard deviation. Or let me get the variance first. Variance of x. Variance of y. Yeah, if you want to get a standard deviation, you can also go for that. And then you can, but let's have the variance. And perhaps you can also look the correlation. Correlation x. So all these keywords that you're typing. So once you have these keywords, it whenever it goes to the library of pandas and it knows when you talk about mean or var or COR or SCRS. So these represents correlation, mean, and variance. So it automatically does that mathematical calculations, and then it gives us the output. Okay, correlation we are actually putting. And if you want, actually, you can very detailedly, you can mention some specific parameters for your data set. So let me look at it. Let me put it as lambda for the value that we're mentioning. And then let me say x dot instead of this one. And that's for the data set and home location. Data set. So we have to make sure if you open like 3 brackets, you also close the 3 brackets. Let me see if I have the correct number of brackets. And perhaps we can try to display, right? Summary. So just make sure your keywords are correct. And number of brackets that you opened, number of brackets you have closed should also be the same. So look at the mistakes that we might have made. Okay, so as we know that for this data set, the mean is same, right? And the mean of X, the mean of Y, the variance remains the same for X and Y, and there is no correlation. So that's why this kind of data sets are really hard to make any distinction between the data set when you look at the descriptive part of the data statistics like mean or variance, even if you look into the other aspects. But when you look into the data itself, there is a huge change. That and this is very easily you can visualize when you visualize it. Let's go further. I think this one you're already a little bit familiar with the way we have been working with this, because we have been talking about this same data set in the past. So maybe you will be wondering like, oh, why do we need such a long thing for correlation? So when you say x dot core, it simply means that it takes in the formula for Pearson's correlation, right? And then it uses for the corresponding values of x and the corresponding values for y. So that's the lambda function formula that we have for x. In this case, we are actually specifying, and then you're actually printing it later on this part. Let's try to use certain scatter plot, I think, which we used earlier, and see whether it works. In fact, yeah, we have put it, but I didn't plot it as such in this case. So if you recall those several things that we have done in the past, just now here, you use this data sets and you use the style as tricks. So I also mentioned that there are different styles that you can use if you wish. That can also change the way that you're visualizing overall. And at this stage, I like to show you one example that we can actually see from their tutorial here. Yeah. So they have separated this tutorial into several parts. As you can see, the tutorials are very specific for like relational plot, distribution plot, categorical plots, regression plots, and multi-plots. And there are themes you can actually specify for different figures and color palettes. And these color palettes are also increasing because, interesting because you can actually set up one color. For example, if you look into just green color, and among the green color, you can actually go from the mild light green to the dark green. Or if you're looking at some colors with two colors, like you want mild blue to dark blue and then mild green to dark green, that can be also be delivered. So that part is well illustrated in this tutorial here. So yeah, there are different color components, as you can see, which you can usually to visualize. And there are different color palettes out there. And sometimes you can actually also mute certain colors as they are seen. So this is the thing that I was mentioning, like, okay. So if you want two colors, as I told you, like you can actually have two colors as such, and then you can see whether it converge or diverge, or for one specific color actually can go this way. In this case, it's blue, but in this case, yellow and brown, right? It goes from yellow to brown. It goes just for the blue. So that's out there. Let's see. Okay, I think in this case they are using the dataset Penguin, right? So Penguin dataset is used, and for this Penguin dataset, actually Penguin also each of those penguins in that dataset they look a little bit different actually. So based on that, you can actually distinguish their flipper length. Based on the flipper length, you can actually see what type of penguin are they. So in this case, it's a distribution. So we are using a distribution plot, right? Visualizing distribution of data. And for this data distribution, generally speaking, we can actually use the bar chart, or you can use the histogram. And yeah, histogram is one of the best way to look at it. So in this case, also we are trying to use this distribution plot, which underlies the code of a histogram. And if you want, we can actually do it right here. Yeah. So this penguin data set is taken. If you recall, we had the penguin data set, and then you're using the distribution plot, and you're extracting this one parameter, which is a flipper length in its x-axis, and by default, the y-axis goes to the number of penguin or count. So the flipper length of 190, we have almost 80 penguins in that flipper length. So likewise, you can see there are certain flipper length for which you can see the number of penguins out there. So this again helps us to see you can actually use simple terms and simple functions, like in this case we just use the SNS dist plot or distribution plot to plot it right there. And if you want, actually you can specify the bin width. So in this case, for the histogram, you have the bins there, and the bin width has been stated to number 3. So let's look at this. So in this case, the bin width is different. Let's look at plot when you have a bin width of 3. It's here. The bin width is only 3. So you can see the x value changes a little bit as you changed. Perhaps you can change further and see what happens. Since it's increasing, the width is increasing. Yeah, keep on increasing. So for any of those distribution plots, if you want to use a histogram, always you should make sure which bin width can really help you to visualize it properly. Okay, so definitely this is not giving us a proper picture. Yeah, so this can help us to visualize it. One distribution plot we have seen. Let's go to one categorical plot. So again, there are a lot of different functions out there, small functions like a scattered plot or relational plot, and very specific plots on these categories are also shown here. So in this example, you can see the total bill, and the categories are days actually. So Thursday, Friday, Saturday, Sunday. Did everybody just run? So specifically, hitting each other. So we are running. Yes. Any questions? Okay. So let's see how we can use it. So this is the categories. As you can see, the Monday, Tuesday, Wednesday, Thursday, Friday. So in this case, specific case, we are using from Thursday, Friday, Saturday, Sunday. So in this 4 days categories, we are going to look at the plot. Let's So the same data set is being used. So you're going for the cat plot, which is a categorical plot. And the category is days, actually, in this case. So that we put on the x-axis, and y-axis is total bill. So what do you think here? So that's the dot represents the tip. And in fact, it's from the dip. The dot represents the total bill, right? Actually, on the x-axis, we have the total bills. And then on the y-axis, we have the total bill. On the x-axis, you have the categories. So you can clearly see if something is not right in Friday, right? It seems we don't have much customers on Friday, probably. I don't know. Usually on Friday night, people used to go out, or maybe they are going out for something else, like for this particular uh, data set, or you can say this particular set of restaurants, you don't have customers on Friday, or something we have to do about it on Friday's business. So that's about the categorical plot. You have many different ways to look at it. You can actually go and use this plot instance. This plot is called a swarm. So when I say swarm, it's like a group of birds flying together or a group of fishes swimming together. So they are called as swarms. So they are trying to use that to visualize a swarm model. So you can actually have a swarm model. And this is quite interesting. It has a swarm model, but it also has categories of male and females. So this is a categorical graph, but among the categorical graph, you have the two labels. That's again a two other categories of male and female comes in, right? So that's a interesting visual part that can help us here. So these are for just examples and tutorials we're just trying to work out. So I have shown you like few examples here. So what I encourage is that go through each of those exercises by yourself, and all the tutorials and exercise given here are workable. When I say it, you can execute it right away and you can see it, it would work. And then try to tweak it, try to change things, and try to see how other values, other functions. There are many other functions are mentioned out there. You can try all those functions. And then we are trying to use all the inbuilt data sets, but why not use, say, a real data set? And the real data set, in fact, you have to use either pandas or other ways to read the data set, like read dot or read.csv. You have to read those CSV files, and then you have to load those CSV files into this system, and then you have to check that out. Since we are talking about it, I just want to show you something. Just quickly, I will show you something like, I'm not going to show you all other aspects. This is one of the project that I'm working on. I just want to quickly show you, like in this case, also you have install pandas, and you install all the libraries that are needed. You import all the things that are needed. So this is the first thing that you should know, like what are the things that you have to import. And then I'm going to give a path for my data set. And then I'm going to define all the variables, like this is a medical data set, and there are a lot of codes out there for specific diagnosis and procedures. So in this case, you can see like fractures, hip fracture, spine fracture, like all these fractures and wrist elements are there. And then you're going to give some specific details about the patients itself. So you're going to read that file, like this CSV file, you're going to read. And then In this case, I'm going to extract the zip codes actually because I want to know urban and rural populations. So you have something called a standard of RUCA. So based on that, you can categorize whether a patient is from urban or rural area. So you are separating that. So RUCA codes. So if RUCA codes is like 1 to 5 is urban, and then like in this case, you can see these are urbans. And if it is like 6, 7, 8, 9, 10, then it's a rural patient. Again, you have to set the path for the diagnosis file so that you can read this file. Initially, you have to load the files, right, and read it. And then you have to check the observation period. Like if you want to check the observation period, you have to look at the admission date when the patient was admitted. So our period of observation is from 2011 to 2023. Then you set some simple screening process because I need patients who are only 65 years and older. In that case, you have to know their date of birth, right? Of course, date of birth is already there in the data set. So until from the starting point of the date of birth, I have to uh, go for 65 years, right? So in that case, this is the total number of patients, among which 42 is male and 58 is female. And you have patients under 65. Among patients under 65, you have 69.84, like at least 70% of the patients are under 65. And then over 65 is like 30.16 patients are over 65. So as you know, like we are only concerned about patients who are over 65 or equal to 65. So I just have to filter that patients out from the original data set. So in this case, the number of patients who are 65 and over is like 177,373. And if you want to separate the urban and rural among them, still you have different races, right? So like American, Asian, Black, African American, white, multiple race, and so on. So that is race category. I'll skip this part for explanation at this point. And you want to know like who have been sustaining certain diagnoses with fracture related disease. So I want to know among those patients who are 65 and above, how many patients are like patients with fracture history, that one. And then I'm looking at a trauma event. When I say trauma event, it means like a patient got uh, fractured and then he was admitted in the hospital. And after that, he is released from the hospital. Once he is released from the hospital, how long does it take for him to get another fracture? So I did this for 5 days. I did this for 30 days, then for 6 months, and then for 1 year. So separately, you have to calculate those elements. So this is nothing visual. It's just all calculations. As you can see, the like different for loops are there for patient specific patient ID and diagnosis. I want to check whether a patient has been admitted again or not with certain diagnosis. Like in our case, whether he has been admitted for fracture. So I have to look at the specific diagnosis part. And then again, I have to check the average refracture rate for those things, those patients. And we have a screening rate, for urban and rural area. And all these things I can visualize, but in this case, I just need the data. And I want to check what kind of medicines they were been taking. So we have to look in for the prescription files. So, okay, I'll stop here anyway. I just want to highlight, you have to load the files. Unlike inbuilt data set that we are looking at in real time or whenever you work with certain projects or other things, you will be given with this data set, which you have to load it and then you have to analyze it. So in this case, I just put prescription underscore star dot CSV, which when I put the star, it means that there is a data set that with same name like did underscore prescribing underscore one underscore two underscore three, any number of files you have, whatever numbers you have out there, all things can be represented just with the star there. So once I put star, it includes all numbers there. So in this example, you have only four out there. So all those four are loaded, and then you are actually checking for some specific medication. So that's out there. Let's come back, and perhaps we can look at another data. Okay, we have seen an example for relational plots. We have seen an example for distribution plot. In fact, we also saw examples for categorical plot. Okay, so here, I'm not sure, like, have you been wondering what is the API? There is a mention of API here. There's a mention of API here. Again, over here, right? So when you, just for instance, if you want to look into this, if you click it there, so these are different APIs available. Like we just saw categorical plot as an example, and then we used cat plot there. And among them, there are different types out there, right? Strip plot, swarm plot, box plot, violin plot. So there are a lot of different parts. So, and then if you look in here, each of those, there is a specific notations to access it. And in other words, what we call it as, you have an instance and you're going to take that instance out there and going to use it. So you can directly use it using seaborn.cat plot. So when I say seaborn.cat plot, it actually refers to that specific categorical plot, and then it actually brings it to the file that you're looking at. Let's go and look in an example for regression plot. Okay, so we're coming back to our tips data set. So we are going to use the regression plots there. It's a simple linear regression, and simple linear regression, how it is going to fit into this X and Y part. So let's copy here. In this example, you are going to put the total billing amount on your X-axis and your tips on your Y-axis. And data are taken from the tips data set. And as you can see, sns.regplot, you can actually, you're actually accessing that regression plot out there. So that's shown here clearly. So all the total billing amount has been plotted. And if you notice, this section here has too much concentration, right? So most of your customers, they dine in for 10 to 20, for 10 to 18 in this case. And whenever somebody dine-ins for more, like 50, for example, and that person usually gives you more tips, right? So those simple changes you can actually analyze in this part. And let's look at one more aspects of that. I think this example we already saw, but let's skip it. That four different aspects. Okay, I think this would be better for us to look in, because you're going to look into this plot, but you also want to use the smoker and non-smoker aspect of it. So let's okay. So we have smoker and non-smoker, so that actually give us more clear information. In fact, if you want, why don't you also check if it's possible for you to visualize based on gender, like a male and female, right? So that's another thing that you can actually uh, dive in. The smokers are given. Let's see, and there are a few more joint plots are also shown here. So here's a simple demonstration of how they actually provide you the grid plot. So if you look in closely, you can actually walk through these examples by yourself. So I'll just go back to the tutorial. Let's see here. So we have seen some simple plots so far. Okay. So this is again another interesting visualizations, like we call multi-plot grids. So multi-plot grids actually give us some relationship, sometimes different correlation between different variables. There are more than one variables out there. You want to use all variables. In this scenario, you can actually go and look into those kind of plots. So we always call it as a multi-grid plot or pair plot. We just mention it as a pair because you are trying to pair up the categories of different data. So specifically, for example, you have if it's a penguin data, you have different species of penguins, or different penguins are there with different in their flapper lengths. So, or if it is iris data, it's based on your sepal width and petal width and petal length. So you can actually provide different types of pair plots. So in this case, there is an iris data set they are using. And for that iris data set, they are using the pair grid plot. So, and specifically they're mentioning they want to see it as a scattered. So in this case, they are using histogram as well as scattered. And this one, they use a hue for species. So the different colors are shown for different species. Let's look into it one by one. Let's load iris data. And as we have seen in the previous uh, classes, iris is one of the other vanilla data set. It's a basic data set that we use, the flowers out there. So we are loading that iris and you're putting the pair grid for the iris. So there's three different species of iris flowers are there. So for those three different species, petal and sepal, or taken. So in this, we didn't specify the specific species, but you do have the sepal length, sepal width, petal length, and petal width, and then again sepal width and petal width for different species. And then let's go for histogram. So you're mapping with this histogram as well as the scatter plot. So you're specifically mentioning that for histogram, you want that to be on the diagonal, right? So if you look in here, all the diagonal elements are histogram. So you're specifically mentioning a histogram to be of the in the diagonal. And for the scattered plot, you're mentioning off diagonal. So all the scattered plots are out there at the other parts except the diagonal one. So off diagonal and diagonals are specifically mentioned for this whole map. And finally, let's look in this. I just want to explain what is going on again. Like, yeah. So what we say here is when you say G equals SNS dot paired grid, it actually creates a matrix. So this is, though we call it as a paired plot, it is kind of a matrix, right? It's a grid of matrix, which has so-called the rows and the columns, right? So you can see the whole thing. It has like rows and columns. So and there is a parameters of specific species are given. So why do we have this legend over here? Because in this particular command, we have mentioned species. And I mentioned that hue, so which means that it has to provide specific colors for these three different species, like in this case, the Setosa, versicolor, and virginica. So these three different species, we have these colors out there. And you can actually plot it with the map function. And you are just assigning them with the diagonal elements, you have the histogram, and the off diagonal, you have the other scattered plot. So basically, that's the whole idea here of using the colors to specify the three different species. And you're mentioning like diagonal and off diagonal elements to be very specific. So if you want, actually, perhaps you can try this out. You can change the histogram. Let's see. I don't if I don't want the histogram, then I can change it. So in this case, I'm changing the diagonal element with the KED plot. Let's see if it works this way. Then it has to, yeah, provide us this simple distribution nature. You can see. So sometimes the same thing has been shown below in a different way. So if you look at this one here, this histogram, the blue one is too tall, and then there's a gap between the blue and the orange one, right? So the same way you can look in here. There's a whole spike there for the blue one, and there's a small, tiny gap, and then the yellow one begins. So what do you think? Which one is better to distinguish these two parts? Like, do you think using a KED plot or a histogram can give us a better visualization when you distinguish between two two different species. In this case, blue is like a setosa, orange is the versicolor. So you are actually clearly see the distinction between these two in this particular pedal width. On the other hand, if you look at sepal width, actually they are merging together, right? If you look in like here, orange and blue are overlapping, and orange, blue, and green are overlapping altogether. So if you look at this using the histogram, maybe it is a little confusing, but if you look at the same thing on this one, perhaps it's better. What do you think? Like this might look better, a little better, right? Yeah. So that's why it's always good to change or you have to see which visualization can really give you the proper mapping. If you really want to correlate, if you want to check or compare with the different parameters. Let's look in, maybe perhaps we can see, I think we didn't see the box plot yet. Let's look at an example in which we can see whether we can put a box plot or a simple, let's see, this is the one the same as earlier, and I'm going to change something over here. Okay. So this is another type of visualization. So what we have done here in the previous one and this one, so we have the scatter plot, but I would put it as the upper part, and the lower part is KED plot, and the diagonal plot is histogram. So diagonal plot is still the histogram is out there, but upper and lower diagonal, like, so this is the upper diagonal and this one is the lower diagonal. So you're actually changing the upper and lower diagonal a little bit. Or what happens if I use a box plot? What do you think? Let's say I change here as if the box plot doesn't really fit in. So the other things is actually it's not fitting in. So which means that box plot is not a proper plot, you could say, to be in for this particular data set. Yeah. So why not like you try a different one? Like if I want to use, say, the same data set, maybe different data set. Let's take a different data set. For this, we used tips. Yeah, here I have used this tips data set. And for this tips data set, I have changed the values like total bills and tips out there. And again, I'm going to change the colors for the gender. let's say if I change. So sometimes it doesn't work all the time because sometimes your data set and your distribution that you're working on or the plot that you're working on really doesn't fit. So in this case, you can see I just wanted to uh, fit, or I just wanted to take in all the information of my say tips data set, and I'm trying to plot it. And just specifically I'm using like sex as a category. I mean, yeah, category like male and female. I'm trying to see how it looks like. Okay, so this has certain features, especially the diagonal elements is still a histogram, and that's it's completely overlapping, right, for male and female, and also for off diagonals, like you have the scatter plot. And I don't know, this doesn't really represent the whole thing properly. As you can see, this two are fully horizontal, and these two are vertical. In fact, if you look in closer, these two elements and these two elements are almost same. Just only thing is it's transposed, but otherwise they're almost same. And again, if you look in closely, this and this is almost same. Again, those two are kind of transposed. So that transposition is the only difference. So which means that it's not really revealing much. You don't really need a paired plot like this to evaluate your data set. Maybe you need a different visualization tool to understand this whole settings. Okay. So so that's the simple introduction. Maybe we'll still deep down into other aspects of data visualization in the coming classes.